Okay, so finite, what does finite mean? It means it ends, right? So for finite series, not infinite anymore, we're talking about finite and we're talking about geometric. It says, suppose that you invest $100 every month into an interest-bearing account with 3% annual rate of interest, right? Annual, but it's a monthly interest rate. So the amount of money that you have after n months would take this form. This is different than interest calculations in the past because now you're adding more every single month. In the past, we would invest like whatever, $1,000 and let it grow. Now I'm putting in 100 and an extra 100 and an extra 100. So this is just showing you that, let's just pretend that this is January, right? January, this $100 gets invested, but I don't have any interest. Well, what happens in February is that I get a monthly interest paid out on January's, and then here's February's $100. So now let's bump it to March. Here's January's $100. It's received interest in February and March. Here's February's $100. It got interest in just March. Here's March's $100. Now move ahead to April. Here's January's 3 months of interest. Here's February's 2 months, March's, and April now has a new $100. So it really is a summation. And the longer you invest, this guy gets more interest than the other ones because it's been in the account for longer. And this was that formula that we talked about using. I just said you could just do the summation on your calculator. We're not going to use this formula. We're only going to use this for infinite. So let me go down here and say, all right, if we wanted for 6 months, how would that look? So in the summation, if I did this process for 6 months, I will have invested $600, right? $100 every single month. The first month gets this 3% interest divided by 12 one time. The second month gets all of this, but then you still have to add on January. So a summation will do it for you. So it says, now let's change it. Let's use the finite formula or your calculator to determine the money after 4 years. So here's where that information gets put. In 4 years, how many months will there be? All right, so you will have invested $4,800, right? $100 every single month. So we have to do 48 calculations. We're putting in $100 every single month, and then it's getting that 3% interest divided by 12. So that's the interest formula that you should kind of recognize. Remember up here, we would do the number of times t, 48. Well, 48 is over here in the summation. In order for a summation to work, you need the variable n minus 1 for your exponent. And that's what people usually forget to do. They want to just put 48 right there. So 48 allows you to plug in 1 and just get January's money. Plug in 2. Now you have January plus February's money with some interest. Plug in 3. Now you have January, February, March with the interest. So if you calculate this out, it will give you the amount of money, the $4,800, plus all of the interest added for each month. So let's try the summation on our calculator. N goes from 1 to 48. So the number of compounds goes at the top of your summation instead of in the exponent over here. So you have 100, 1 plus 0.03 divided by 12 raised to the n minus 1. So you should all try typing it in. It does make sense? You know that it's more than $4,800 because you invested $4,800, $100 every month. And then you got interest on the early stuff, a lot of interest. The later stuff didn't get much interest. I got 5093. Is that what you got? I got 5093 and 12 cents. What number? Yeah, that. I don't know if you can see it better on here, but You have to make sure that the parentheses are outside. You don't need an extra parenthesis. You just need one around the parenthesis 1 plus 0.03 divided by 12 parenthesis. So that's your basically interest rate. And then the n minus 1 power has to be inside the summation. So the summation tells you how many months to do it for, and x minus 1 up here allows you to plug in the first month, plug in the second month. There has to be somewhere to plug in for x. Did we get that now? Maybe. All right, so let's look at the next one. Now it says instead of 100, how much should you invest, still at 3% annual interest compounded monthly, to have $15,000 at the end of 6 years? So what needs to change in this summation? The 100, I don't know what the 100 has to be. I'm going to call it X. And what else has to change for it to be 6 years? Right. So 72 months now instead of 48 months. So this is one big old X. I don't know how much to invest. So I'm going to show you a trick on how to do this without having to guess and check. This X, right, is really just going to be multiplied by 72, isn't it? So like if you invested 40, you're investing 40 times 72 months. So it's really the distributive property. So it doesn't matter if you take that X and just do it at the end, kind of like the distributive property. So you can move this unknown amount outside of the summation and just treat it like a constant so that you could actually type this summation into your calculator and get a number. And then if you set your equation equal to 15,000, which is your goal, if X times this number has to equal 15,000, whatever you get with your summation, you can just divide to the other side to get X by itself. That way you won't have to guess and check what X is. So we're going to type this summation with everything as is without that X there, get a number, like if the number is 7, then we're going to take 15,000 and divide by whatever we get, like 7 to the other side. So you're typing in the summation without your starting value. So just put the parenthesis and this 1 plus 0.03 divided by 12 directly inside your summation. So see what you get as your investment that you need. This is what a retirement analyst will do for you. Like, okay, you want to have $2 million by the time you're 65. How much do you have to invest in your retirement account every month at 8% return rate for the stock market or something like that? They're using this exact formula to help you save for retirement and predict what do you want to have, how much do you have to invest from your paycheck every month. $190.4 is what I got. What did you get as the summation amount? Did you get $78 or 78.78? So then I took that 78, I just took the full amount. I took 15,000 and divided by my answer to get the $190 and 40, I guess I should round up, 41 cents. If I only invest 40 cents, I'm not going to quite make it. So I just type 15,000 divided by, the second answer key is above the minus sign, or you could just arrow up, highlight the number that you want and hit enter, and it'll put the whole answer in it for you. Maybe arrowing up is the easier way. So it was $190.41 per month, and that would help me reach my goal. All right, so this time it changes. How much should you invest each year at 5% annual interest, compounded annually, in order to have $75,000 at the end of 20 years? So how is my summation going to look different? I know I need to get to 75,000, right? N has to go from what to what? How many times is this going to get compounded? Huh? Just 20, right? So, oops. Again, I'm trying to just figure out what I need to invest, right? So I'm solving for X at the end. How do I write my interest formula? It's just 1.05, right? Because the 5% is just getting divided by 1 because it's annual. And then I'll put n minus 1 up in the parentheses. So I can plug in 1 year, plug in 2 years. So just like I did in the last problem, I'm allowed to take out this constant and slide it out front as a multiplier. So I can just do the summation on the interest, take the 75,000 divided by that interest, and it'll generate my value that I have to invest every year. So this would be an annual investment. Like, you know, at the end, right before tax season, sometimes people put aside money into their retirement account to be like, all right, I'm going to reduce my taxes by investing in my retirement account. So how much do they have to put in every single year? And make sure to actually do the last step of taking 75,000 and dividing by that value. So I got from my initial number 33, that's what I took 75,000 and divided by, and I got 2,268 and then 19 cents, or if you want to round up to 20 cents, because there's this decimal over here. I mean, I would accept either as the correct answer. 2268.19. I mean, if you really needed to have 75,000, you better put in that extra penny so that you don't end up short a few pennies at the end. All right, so that is a finite geometric series. Why did it have to be finite? Because remember my R value, all these R values are bigger than 1. So if it goes forever, it's just going to get bigger and bigger and keep growing forever. On the back page, it's reminding you about infinite geometric series. So this could go on forever because the R value is less than 1%, like 60% is 0.6. So here's an idea that a logging company treats logs with a toxic chemical that enters a holding pond. So they're treating, you know, pressure treated wood or logs so they don't rot. So they put the logs in a holding pond of water, but they put this chemical in the pond. So it says there's 8 kilograms of chemical in the pond at the beginning of each month. So they like shock the pond again with 8 kilograms of this chemical. During the month, 40% of the chemical dissipates, meaning like it evaporates out of the pond. So it says find the amount of chemical after 3 months. So they keep adding chemical and it dissipates. They add chemical and it dissipates. So here's showing what happens. The first month, they just dump it in. Then in the second month, right, they only have 60% of that original 8 kilograms, but they shock it again with 8 new kilograms. And then this guy's over here now, because it's dissipated over 2 months. This guy's now over here, dissipated 1 month. And then here's, I shocked it again with 8 new kilograms. So see how it is a summation over time. So evaluating S sub 3 is n goes from 1 to 3 of 8 times 0.6 to the n minus 1 power. And we're using 60% because you want what you keep, not what you throw away or dissipate, because then you'd have to subtract off the 40% of stuff every time. So what is S sub 3? So how much is left after the third month? So when you go from 1 to 3 of 8 kilograms at 60%, this takes into account month 1, month 2, and month 3, just like it did above. What would you get? I don't know if you typed it in correctly. You did 8 times the 0.6 to the n minus 1? 15.68 kilograms, yes. So it does become more than 8 kilograms over time because you're adding 8 and not all of it's going away. You're adding 8 more, not all of it's going away. So the EPA, Environmental Protection Agency, probably wants to make sure that we're staying below a certain amount, right? We don't want this to leach out into the environment or kill whatever we kill, plants, I don't know. So they probably want to keep the amount of chemical checked. So you as the plant manager, you don't want to be in violation and get shut down. So you need to know mathematically how much chemical can I put in and stay within the EPA's guidelines. So this says, what if this just continues forever? So every single month, we keep adding 8 kilograms. Are we going to stay in regulation? So the infinite formula, you need to know. It's the first value divided by 1 minus r, right? That's like making this go to infinity. So instead of typing in infinity here, we take the first value, 8. R is ratio, the common ratio. So we're taking 8 and dividing by the 1 minus 0.6. So 8 divided by 0.4. So where is this going to max out? Yeah, it's going to max out at 20 kilograms. It's never going to get to 21. Right? And I can kind of prove this to you by, if I take my summation and make it go like 1,000 months, well, maybe I'll do 100. 1,000 might take a really long time. Oh, it actually already converged to 20. So it's maxing out at 20 kilograms. So it says, will the maximum concentration ever exceed the federal limit? No. But it says, will the maximum concentration ever exceed the state limit? So the state limit's 19 kilograms, and it says, how long will this take? So you need to kind of guess and check. We know that it's more than 3 months. So what I would do is plug in month 4, 5, and 6 and see when does it cross that 19 kilogram limit. So you can kind of just arrow up, grab your summation on your calculator, see what it is after month 4 or 5 or 6. So depending on what state you're in, if they change the EPA guidelines, you might have to adjust how much you're going to shock your pond with, right? Because you don't want it to go over. Or maybe you'll skip a month and let it go back down before you add more. So what month does it go over? Did you figure it out? Yeah, I got month 6 was 19.07. So month 6, they're going to be in violation. I'm sure businesses go in violation sometimes, right? So it depends on, oh, well, we know we're going to be over this, huh? Yeah, right. It's going to plateau and then slowly, slowly, slowly get to 20. It actually never gets to 20, right? It gets to 19.9999. So I think even if 20 was the limit, they never break 20. They're never over 20. All right.